Okay, on 5.3, the topics are going to be looking at radical functions and graphing them and determining the domain and ranges of them. So, for example, we have two types of parent functions. One's the square root, and the other one is the cubic root function. And so the square root function, notice that there are no negative x's because then it would be undefined. And notice that the y has got to be greater than 0 because this has got to be positive. When you have a cubic, you can have negative x's. And notice that there is symmetry here about the origin, or it would be an odd function. The domain would be all real numbers. The range would be all real numbers. Let's go ahead and graph a couple of these and talk about the transformations. This one is going to be to the right 3 and up 4, which means that we have a point that instead of it looking like this, it's now going to go 3 this way, 4 up, and that's going to be your starting point. So instead of it being at the origin, it's now at 3, 4, and it's going to come across like this. If you want to get another point, let's see what would make sense here. 4, and if you put in 4 here, you're going to get a 1. Square root of 1 is 1, so that's going to be 5. Looking at this one, okay, so a couple things. First of all, this is a horizontal, and it's by a factor of 1/8, so it's going to be a shrink. It's going to go away from the horizontal axis by 1/8, and then this negative is applied to the x, which means that it's going to reflect this way. And so there's a reflection over the y-axis. Now notice that on this one, a positive x becomes negative and a negative x becomes positive, and that's why I draw that double arrow. So now we're going to try to graph this. So the normal graph looks like this. And now we've got to reflect it over the y-axis, which means it's going to come like this, and it's going to be a lot wider from the horizontal axis. So it's going to come up like this and come down, and that's not good enough. Let's see if this can be any better. It's going to be coming down, and then it's going to be coming back like that, real wide. And you want to put a couple points in there. A good point would be where it's 1. 1 means -8. The cube root of -8 is -2. So your 1, -2 works, as well as -1, +2. And that graph is enough to understand that you know what you're doing. All right, the last problem, let the graph of G be a horizontal shrink by a factor of 1/6. So that means that your A is going to be equal to 6 because it's horizontal. So one you have to be careful with, followed by a translation of 3 units to the left of the graph. So here's your f of x. We're going to write g of x equals, and I could do a couple things here. I could say f of, let's see, 6 times x is going to be the horizontal shrink. And then I could also say, well, it's going to be a substitution for x plus 3. Now be really careful about that because it's in parentheses here. You're substituting that x plus 3 in for x. Now, what happens on your g of x when all this is going on? So it becomes the cubed root of, okay, so it's going to be 6 times x plus 3, which means that it's going to be the cubed root of 6x plus 18 is your g of x. That right there is going to be a mistake. Notice it has to be in parentheses.